Hello friends, welcome to today's lecture Analysis of Trusses. Lecture number 4. Myself Mr. Y.S. Patil, Department of Civil Engineering, Sharad Institute of Technology, College of Engineering, Yatra. So let us see one problem. In last lecture we discussed or we solved problem that the statically indeterminate structure or that truss is internally indeterminate, means that equation is m is equal to 2j minus 3 is not satisfied, so that truss will be imperfect truss. Now in this problem the truss is perfect but the indeterminacy is external means we know the equilibrium conditions, that is summation fx is equal to 0, summation fy is equal to 0 and summation m is equal to 0. This is the three equilibrium conditions. If the number of unknown is 3 and the equation is 3, the structure is determinant. If the number of unknown or number of external reactions is more than 3, then the structure will be externally indeterminate. So let us see one problem. Calculate the forces in all members of the frame shown in figure. The cross-sectional area of a vertical member are 320 mm square and those of all other members are 190 mm square. So this is the structure or this is the truss is given. So vertical member is 320 mm square, that is AB and CD, and all remaining members are 190 mm square. And the external applied three loads, that is 45 kN at point B vertically downward, 45 kN at C vertical downward, and 45 kN horizontal towards the right side at point B. So at point A and D is hinge supported. So hinge supported, number of reactions for hinge is 2, that is vertical and horizontal. So total number of reactions at A is 2 and at D is 2. So total number of reaction is 2 plus 2, that is 4. And we know that the equilibrium conditions of number of equations, that is 3. So 4 minus 3 is equal to 1. Let us see the structure or the truss is perfect or imperfect. So first calculate number of members. 1, 2, 3, 4 and 5. So m is equal to 5. Number of joints 1, 2, 3 and 4. So joint is equal to 4. So we know that equation is equal, m is equal to 2j minus 3. So 5 is equal to 2 into 4 minus 3. So 5 is equal to 5. So this truss is analyzed by using that regular method of joint or method of section. But at support A and at support D both are hinge support. So number of reactions is 4 and we having only 3 equations. So indeterminacy will be 1 and that indeterminacy is external indeterminacy. So if you want to analyze this structure, you should remove one horizontal force, that is RDH. When you remove that RDH, the number of reactions at point D is 1 only, that is RDV, and at point A is 2, that is RAH and RAV. Then the structure will be determinant. So let us remove RDH or assume that RDH is a redundant force. So after removing this RDH, the only one reaction is present, that is RDV. At point A there is RAH and RAV. And our remaining truss is already perfect truss, so we can easily solve this truss. So first of all calculate RAH. RAH is equal to summation fx is equal to 0, number of forces in horizontal direction, right side is equal to left side. So number of forces going on the right side is 1, that is 45 kilonewton. And number of forces going on the left side, that is RAH. So RAH is equal to 45 kilonewton. Then next summation Fy is equal to 0. Upward force is equal to downward force. So total number of upward forces is 2, that is RAV and RDV. So put up on the left side, that is RAV plus RDV. And then number of forces going in a downward direction is 2, that is 45 and 45. So 45 plus 45 is equal to 90. So we get equation RAV plus RDV is equal to 90 kilonewton. Then next, summation M is equal to 0. Taking moment about this A point. So number of moments with respect to A, this 45 kilonewton, this 45 will be 0 because line of action coincides with point A, and this 45 means due to that external forces 2 moments are there, and due to that reaction RDV is only moment. RAH and RA will be 0 because the line of action coincides with point A. So 45 into this 3 distance, then 45 into vertical distance 6 and RDV into 3. So RDV value is equal to 135 kilonewton. So we having equation that RAV plus RDV is equal to 90. So put up RDV in this equation. RAV value is equal to minus 45 kilonewton. The minus sign indicate whatever we first assume that RAV going in upward direction, our assumption is wrong, that RAV actually going in a downward direction. This negative sign indicates our assumption, whatever we assume, that assumption will be wrong. So RAV is a 45 kilonewton but direction is downward. So first solve this truss. Consider joint A. At joint A, number of forces meet at A is RAV, that is 45 kilonewton downward direction, RAH 45 kilonewton towards the left side, and two member, that is FAB, and one inclined member, that is FAC. The inclination of that FAC member is 63.43 degree with respect to X. So summation Fx is equal to 0. The horizontal forces right side is equal to left side. In this system, first that one inclined force, that FAC, first of all that FAC split up into two perpendicular components. That X component will be FAC cos 63.43 and the direction of that FAC force is a right side. And that Y component for that FAC is FAC sin 63.43 and the direction is upward. So in this system the horizontal forces will be 2, that is RAH and FAC cos 63.43. That FAC cos 63.43 going towards right side and RAH going towards left side. So RHS, R right side is equal to left side. So FAC cos 63.43 is equal to 45. So FAC is equal to 45. This cos is a multiply on this side, divided will 45 divided by cos 63.43. So FAC is equal to 100.60 kilonewton. Same way we use summation Fy is equal to 0. Upward is equal to downward. So in this system total number of vertical forces is FAB. That Y component for FAC, that is FAC sin 63.43 and RAV is equal to 45 kilonewton. Out of these three forces, two forces going in upward direction and one force going in a downward direction. Plot upward side one side and downward side another side. So upward side FAB plus FAC sin 63.43 is equal to 45 kilonewton. So put up FAC value in this equation, the unknown only FAB. So FAB will be minus 45 kilonewton. The minus sign indicate whatever we assume, the assumption will be wrong. So means FAB, basically FAB we assume that tension, but that negative sign indicate there is a, in member FAB there is a compression force. Consider joint D. At joint D, number of forces meet is 3, that is RDV is 135 kilonewton, FCD and FBD. FBD is the inclined force at an angle of 63.43 degree with respect to X. So this FBD split up into two perpendicular components. First X component, this X component going in the left direction, that is FBD cos 63.43, and y component in upward direction, that is FBD sine 63.43. So summation fx is equal to 0. So x in the x direction, total number of forces is single force, that is FBD cos 63.43. There is no second force, so FBD value will be 0. Then next, in the y direction, total number of forces is 2, that is RDV and FCD. FBD will be now considered as a 0. So there is only two forces, that is RDV plus FCD. FBD sine 63.43 will be 0. So FCD is equal to minus 135 kilonewton. Then next, consider joint B. At joint B, there is a two external forces, that is 45 kilonewton horizontal, 45 kilonewton vertical, and three member forces, that is FAB, FBD, and FBC. FAB is a vertical, FBC is horizontal, but this FBD is a inclined force. So split this FBD into two perpendicular components, and we know the value of that FBD is a 0, so there is no need to consider this force. So first consider summation fx is equal to 0. In the horizontal direction, two forces are there. There is 45 kilonewton and FBC. Both are going in the right side. So 0 is equal to FBC plus 45. So FBC is equal to minus 45 kilonewton. Then next, summation Fy is equal to 0. So vertical forces is two forces, that is 45 kilonewton and FAB. So both forces are going in a downward direction. So 45 plus FAB is equal to 0. So FAB is equal to minus 45 kilonewton. Then next, this is we first find out the forces in the member due to external loads. Now remove all external forces and apply a unit load at the redundant force. So at point B, there is a two external forces, that is 45 horizontal, 45 vertical, and at point C 45 vertical. So remove all these three forces and apply redundant force at D. Basically RDH, we assume that the redundant force. So at RDH apply 1 kilonewton force horizontal direction. So there is no vertical forces in the system. So RAV and RDV is equal to 0. Then RAH is equal to 1 kilonewton, because at point D 1 kilonewton going on the right side. So RAH is equal to 1 kilonewton on the left side. Then we need to find out K forces, or this forces in the member due to this 1 kilonewton applied force. So find out K forces for all members. First consider joint D. At joint D, 1 kilonewton, this is the applied force. Then KCD and KBD. This KBD is a inclined force. So split up into two perpendicular component. For X component going on the left side, Y component going on the upward direction. So KBD cos 63.43 is a X component and KBD sin 63.43 is a Y component. First consider summation fx is equal to 0. So in the system, two forces are in the horizontal direction, that is 1 kilonewton and KBD cos 63.43. This 1 kilonewton going on the right side and this KBD cos 63.43 going on the left side. Then KBD is equal to 1 divided by cos 63.43. Then KBD is equal to 2.23 kilonewton. Then summation Fy is equal to 0. In the system, there is a two vertical forces, that is KCD and Y component for that KBD. So KBD sin 63.43 plus KCD, both are going in upward direction. So put up on the same side is equal to 0. Then put up this KBD value in this equation, and that KCD is equal to minus 2 kilonewton. Then consider joint A. At joint A, there is one RAH force, that is reaction at A, then KAB and KAC. Once again, this KAC is an inclined force, so split up into two perpendicular components, that is KAC cos 63.43 going on the right side, and Y component is KAC sin 63.43 in a upward direction. So first consider summation fx is equal to 0. So total number of horizontal forces is 2, that is RAH and KAC cos 63.43. This force going on the right side, this force going on the left side. So 1 is equal to KAC cos 63.43. So KAC is equal to 2.23 kilonewton. Then summation Fy is equal to 0. In the system, two forces in the vertical direction, that is KAB and KAC sin 63.43. So KAB plus KAC sin 63.43 is equal to 0 because these two forces going in a upward direction. Then KAB is equal to minus 2 kilonewton. Then consider joint B. At joint B, three forces or three members meet, that is KAB, KBD, this is inclined force split up into a horizontal and vertical component, and KBC. Already KBD is a known term, KAB is also known term, only unknown is KBC. So only use summation Fx is equal to 0. So total number of horizontal forces is 2, that is KBC and KBD cos 63.43. Both forces are going on the right side. So KBC plus KBD cos 63.43 is equal to 0. So we know the value of the KBD is minus 2.23. Cos 63.43 plus KBC is equal to or 0, and that KBC is equal to minus 1 kilonewton. So tabulate this all P forces, K forces, length, area in this table for all members. For member AB, P is a minus 45 kilonewton, K is a minus 2, length for that AB is a 6, and area for that AB is a 320. Similarly, put up BC, CD, BD, AC. All P forces, K forces, corresponding length and corresponding area. Then in this column we calculate PKL upon A. This PKL upon E. So for that member AB is 1.68, for that member BC 0.71, for member CD is 5.06, for BD is a 0 due to this P force is equal to 0. Then for AC is 7.90. Then in this column we calculate K square L by A. K square L by A. Put up K L divided by A. So K square L for that AB is 0.075. For AB, for BC 0.015. For CD 0.075. For BD 0.175. And for that AC 0.175. So summation for that PKL by A is 15.35 and summation for that K square L by A is 0.515. Next, find correcting factor X. For correcting factor X, there is a formula, that is summation PKL by A divided by summation K square L by A. Minus this PKL by A is 15.35 and this K square L by A is 0.515. So value will be minus 29.81 kilonewton. This is a minus 29.81 is a correcting factor. Then final forces in the member of the redundant is equal to this formula for find out the final forces is Sx is equal to F plus K into X. For suppose for F's final force in member AB is force in member AB, that is minus 45, plus K for AB, that is KAB minus 2, and that correcting factor is minus 29.89. So minus 45 plus minus 2 into minus 29.89. So yes, final force in that member AB is 14.62 kilonewton. Similarly, for that final force in member BC is minus 15.19 kilonewton. For that CD is minus 75.38 kilonewton, and for that BD is minus 66.47 kilonewton, and for that AC is 34.12 kilonewton. This is the final forces in the member. This problem is externally indeterminate. This is the solution for that problem. Thank you.